In this video for Math 98, we'll be covering problems from section 14.3 and 14.5. These cover problems on homework 9, and these problems are like problems 1 through 10 on the homework. In particular, this is a continuation of the last video, and we're going to look at application problems involving systems of three equations with three unknowns. I'm also going to show you some calculator techniques that make this process a little easier. So let's talk about solving problems with three equations and three unknowns. Here's an example. An ounce of macadamia nuts contains 222 calories. There are twice as many grams of carbohydrates as protein. The total weight of carbohydrates, protein, and fat in this ounce of macadamia nuts is 28 grams. Protein and carbohydrates have 4 calories per gram. Fat has 9 calories per gram. How many grams are there of each of carbohydrates, fat, and protein? So when solving an application problem, the first question you should ask is, what is it that I want to know? In this problem, I want to know how many grams of carbohydrates, fat, and protein do I have in my ounce of that macadamia nuts, given all these conditions. So I need some variables. I'm going to let the variable x equal the grams of carbohydrates. So I'm trying to identify my variables right now. I'm going to let y equal the grams of fat, and I'm going to let z equal the grams of protein. Okay? Now, what do I know? Well, I know that my total weight is 28 grams, and I know that the protein and carbohydrates each have 4 calories, and that fat has 9 calories per gram, and I know that the total is 222 calories. It might be useful in this problem if I made a table, and here's the table I'm going to make. So I have 3 items under question here. Okay, those 3 items are carbs, carbohydrates, I'm just going to write carbs here, fat, and protein. And this is going to be how many grams of each of these I have. And this is going to be the calories per gram. And if I take the number of grams times the calories per gram, I'll get the total number of calories I have. Now, pretty obviously, however much grams of carbohydrates, fat, and protein, that will give me a certain number of calories, and these calories have to add up to the total number of calories in my example. Now, so I have x grams of carbohydrates, y grams of fat, z grams of protein. I know that protein and carbohydrates each have 4 calories per gram, and that fat has 9 calories per gram. So just using this simple multiplication across, I have 4 times x for the amount of calories contributed by carbohydrates. I have 9 times y for the amount of calories contributed by fat, and I have 4 times z for the amount of calories contributed by protein. I know that I have a total of 28 grams, and I know that I have a total of 222 calories. This gives me the following equations. X plus y plus z equals 28, and 4x plus 9y plus 4z equals 222. I need one other piece of information, and I'm going to go back to the problem to look at it. You'll notice the second sentence is there are twice as many grams of carbohydrates as protein. What that means, for example, is if I had 30 grams of protein, I'd have 2 times that amount to be the amount that I would have in carbohydrates. So I'd have 60 grams of carbohydrates. So if I have z grams of protein, I'm going to take that and multiply by 2, and that will give me my grams of carbohydrate. Well, look what I have here. I have a system of 3 equations with 3 unknowns, and maybe we ought to take a moment and try to solve this. So I ask you to maybe stop the video right now and see if you can do this yourself. Okay, it's pretty clear that this equation right here is already solved for x. So I can get 2z plus y plus z equals 28. That result gives me 3z plus y equals 28. And here I can get 4 times x, which is 4 times 2z. So using this one, 4 times 2z plus 9y plus 4z equals 222. That gives me, let's see, that gives me 8z plus 9y plus 4z equals 222. That gives you 12z plus 4y, 9y, excuse me. Thank you, sorry about that, equals 222. So I have this equation, and with this equation, I now will move forward. I'm going to give myself a little bit more paper here to work with this. So I'm going to use these system of equations. I'm going to multiply the top one by minus 4. So minus 4 times 3z plus y equals 28 times minus 4. That will give me minus 12z minus 4y equals 28 times 4. 28 times 4 is going to give me 112, so that's negative 112. And I'll write this next equation, 12z plus 9y equals 222. Now I'm just going to add these two together. That cancels out the z's. This gives me 5y equals 222 minus 112, which is 110. And I finally get that y equals 22. So there are 22 grams of y. Now, we can go back into one of these equations and find z. So I have 3 times z plus y equals 28. So y was 22. So 3 times z plus y equals 22. So 3z equals 6, or z equals 2. So z is 2, y is 22. To find x, I'm going to use this equation. So x equals 2 times z, which is 2 times 2, which is equal to 4. Now let's go back and interpret this answer. If you remember, x was the grams of carbohydrates. So there are 4 grams of carbohydrates. Y is the grams of fat. There's 22 grams of fat. And z is the grams of protein. There's 2 grams of protein in this little ounce of macadamia nuts. So that was a lot of work in the solution. You needed to set up the equations. Once you set up the equations, you need to solve them and then interpret your answer. Let's look at another problem, maybe one that you might be familiar with too. Let's take a look at this example. Shelby has 625 in nickels, dimes, and quarters. There are 48 coins altogether, with 3 more quarters and dimes. How many of each type does she have? So this time I'm going to let n equal the number of nickels. It's important to identify your variables. And d equal the number of dimes. And q equal the number of quarters. I'm going to make a table again that might help me organize my work. So I know I have nickels, I have dimes, and I have quarters. And here I have n, d, q. So this is the number of these that I have. I want to multiply that by the value of each coin. So a nickel is worth $0.05 or 5 cents. A dime is worth $0.010 or or 10 cents, and a quarter is worth 0.25. So that's going to give me the total amount of money that each of these contributes to the total sum. So this is 0.05N, this is 0.10D, and this is 0.25Q. Now, I know that I have a total of 48 coins altogether, and I know that I have $6.25. So I can write down from this the following equations. N plus D plus Q equals 48, and 5 cents times N plus 10 cents times D plus 25 cents times Q equals 625. And now I need one other piece of information that was given in the problem, and that is there are 3 more quarters than dimes. So the number of quarters is 3 more than the number of dimes. So here we have our system of equations, 3 equations with 3 unknowns. So let's go ahead and solve this again. I already have Q isolated, so I'm going to use that to help me with my equations. So my first one is N plus D plus Q, but instead of Q, I'm going to write 3 plus D equals 48. Doing the arithmetic here, I have N plus 2D plus 3 equals 48, or N plus 2D equals 45. So there's my next equation. Now I'm going to use this for Q in this one. That's 0.05N plus 0.1D plus 0.25 times Q, but instead of Q, I'm going to use 3 plus D, and that gives me 6.25. That gives you 0.05N plus 0.1D plus 0.75. Okay, I'll multiply this in, plus 0.25D equals 6.25. Okay, keep going. I've got 0.5 times N. I've got here, you notice, 0.35D. And if I subtract 0.75 from both of these, I get 5.5. So I have this equation and I have this equation. Let's see what we can do to solve these. This time, I think to solve these, I will solve this equation for N. I'll use substitution, 45 minus 2D, and substituted that into my original equation here. 0.5N is 45 minus 2D plus 0.35D equals 5.5. Now, so if I distribute this, I do 0.05 times 45, that's 2.25. 0.05 times 2 is minus 0.1D plus 0.35D equals 5.5. This gives me the minus 0.1D, and the 0.35D gives me quarters again, 0.25D. And if I take 5.5 to minus $2.25, that gives me 3.25. Oops, sorry, you can't see that. Divide both sides by 0.25. So do this. 3.25 divided by 0.25 is 13. So I have 13 nickels. If I have 13 nickels, how many dimes do I have? Let's use this equation right here. I'm sorry, I have 13 dimes. Sorry about that. So let's use this equation to tell you how many nickels. That's 45 times 2 times 13. 2 times 13 is 26. So that's going to be 19 nickels. And here, 19 and 13 and quarters equals 48. So 19 plus 13 is 32. So I need 48 minus 32, or 16 quarters. So that's my answer. 13 dimes, 19 nickels, 16 quarters. As you can see, the process of doing these is pretty difficult. So is there an easier way to using my calculator? The answer is yes. I, however, warn you that some instructors may not prefer you to use this way until you get a little further in mathematics. But it certainly is time-consuming to use this system of equations, 3 equations, 3 unknowns, by elimination or substitution. So if you wanted to use this on a calculator, we're going to create something called an augmented matrix. And without going into too much detail, I'm going to ask you to put the coefficients, the number in front of A, in this first column. So this would be 1, minus 1, and 2. The numbers in front of B in this one, 1, 1, minus 1. And the numbers in front of C in this one, C. Notice there is no C here, so we're going to put a 0. And C here, this is 1. And then my constants, which are these numbers, 29 and 0. This structure is called a matrice, or a matrix, and we can use our calculator to help us with this. If you go over to your calculator, you'll notice above the x1 is the word matrix. I want you to hit second x1. Now, this first column is for names. These are the names of your matrix. And I suggest you use this first one. Ignore these numbers for the moment. Use your arrow keys to go over to edit and hit enter. Now, what do these numbers mean? These numbers are counting the number of rows, that's the first number, and the number of columns in your matrix, that's the second number. So we have 3 by 4. So just enter 3, enter, 4, enter. If you have something there, that's fine. We're going to change it. And I'm just going to type across. 1, enter, 1, enter, 1, enter. Notice it will pop over here. 20, enter. Then go down, minus 1, enter. Make sure you hit enter after each one. 1, enter, 0, enter, and then 9, enter. 2, enter, negative 1, enter, 1, enter, 0, enter. Now, if you look at this, you will see that this is equivalent to this right here. Your next step is to say second quit. Then here's the hard part, but you'll like it. Second x to the minus 1 for matrix. Use one arrow over to go to math. Scroll down for quite a while until you get to this right here, RREF. That stands for row reduced echelon form. That's not something we cover in this class, but go ahead and just hit enter on that. Then I have to put in the name of the matrix. Do not type the letter A. You have to get the name of the matrix by doing this. Second matrix, number 1. Okay, put an end parentheses, hit enter. Here is your answer. This is what you get after you get RREF. Now, that's 1, 0, 0, 2, 0, 1, 0, 11, and 0, 0, 1, 7. Now, what does this mean? Well, the first column, you might remember, represent A. So this is 1 times A plus 0 times B, not going to write that down, plus 0 times C, not going to write that down, equals 2. This represents 0 times A, not going to write that down, 1 times B, plus 0 times C, not going to write that down, equals 11. And this represents 0 times A, 0 times B, 1 times C equals 7. Do you see? This is your solution. So this is a great way to check your work. Let's try another one. Maybe you want to set this up yourself. First, let's write the augmented matrix. So I'm going to take my A's and write them down here. 1, 6, 1. And my B's, 2, 7, 1. And my C's, 3, 8, 1. And then my constants, 2, 3, 1. This, again, is my augmented matrix. It is what we're going to use to help us do this on the calculator. So I'm going to go back to my calculator, bring it in here, and I'm going to write down these steps here. Second, x to the minus 1. These keys give me the matrix menu. Use 2 arrows to go over to edit, then hit enter. Then you want to type in the size of the matrix, which is 3 by 4, and then type in your numbers, remembering to hit enter after each one. So that's 1 enter, 2 enter, 3 enter, 2 enter. Notice you have to go across the columns. 6 enter, 7 enter, 8 enter, 3 enter. 1 enter, 1 enter, 1 enter, 1 enter. You might check that it is correct. Then I want you to hit second mode. That's the quit key. And then this RREF again. And the way to get that is second x to the minus 1. Go over one arrow to math, and then go down all the way to the letter B. Use your down arrows to the letter B. Hit RREF. Then you have to get the name. That's second x to the minus 1 again. And if you're using A, which I might assume you always do, just hit enter, end your parentheses, hit enter again, and here is your solution. Now, this solution I purposely made a little weird. So look at what matrix we got here. We got this one. Let's try to analyze this. Remember, these are my A's, my B's, my C's, and these are my constants. Okay, sometimes somebody writes a little line in there for you to realize that. This gives you A minus C equals 0. The second one gives you B plus 2C equals 0. This last equation gives you 0 times A, 0 times B, 0 times C, which is 0, equals 1. Now that, of course, is ridiculous. That's just plain wrong. What does that mean about this system of equations? That means this has no solution, so that this is a contradiction. So you can use this technique even when there isn't a solution. Let's try this one both ways. I would like to look at this problem in both ways, both with and without the calculator. So let's take a look at this the old-fashioned way. And I'm going to use the elimination method. I'm going to call this equation 1, equation 2, and equation 3. And equation 1, I'm going to do, well, I'm going to do negative 2 times equation 2, and I'm going to add that to equation 1. So I'm going to write down equation 1, 2a plus b plus c equals 3, and I'm going to multiply negative 2 times equation 2, which is minus 2a minus 4b plus 6c equals negative 4. Okay, so double check that we have done that correctly, and I'm going to add these together. That gives me minus 3b plus 7c equals negative 1. This I'm going to call equation 4. Now, I'm going to take negative 1 times equation 2, and I'm going to add that to equation 3. Remember, I need to eliminate the same variable, so I need to use this to do that. So I'm going to multiply negative 1 times equation 2. That's negative a minus 2b plus 3c equals negative 2. And equation 3 is a minus b plus 4c equals 1. If I add these together, I'll get negative 3b plus 7c equals negative 1. That's interesting. If I look at these two equations, I'll notice they're the same. This should give you a hint. Something weird is going to happen here. But let's just continue with my elimination method. I'll write these above each other. I'll multiply this first one by negative 1. And so I'll write that down. That's 3b minus 7c equals 1. The second one is minus 3b plus 7c equals negative 1. If you add these together, you get 0 equals 0. What that means is that that means that this is what we call an identity, meaning it has multiple solutions. There's an infinite number of solutions. So that's kind of interesting. That's the other special case we have. I'm going to go back to my original problem, and I'm going to do that on my calculator. So you remember how to do your augmented matrix, hopefully. This is 2, 1, 1, 1, 2, negative 1, 1, negative 3, 4, 3, 2, 1. I'll give you a moment to do this. Okay? Quit. Second matrix, go over to math, go all the way down to B, hit RREF, then second x to the minus 1, select the first one, hit enter. Oh, that's hard to read. I'm going to hit math, number 1. Now I can read it a little better. Do you notice this bottom row is a row of zeros? This first column gives me A plus 5/3 C equals 4/3. This second row gives me B minus 7/3 C equals 1/3. And this last row gives you 0 equals 0. If you get that 0 equals 0, that means you have an identity and you have infinite solutions. I hope you have found this video useful.